Can people hear me? If someone can just pop a message in the chat, that would be really useful. People can hear me. Good. Looks like I need to subscribe to Norfolk developers before I can reply to the chat. That's quite embarrassing, isn't it? Two seconds, and I can then talk to all of you lovely people. There we go. Lovely. Well, thank you all very much for coming along this evening. Hopefully it will be entertaining, useful. There is no real kind of format to these. If you've been to one of these streams before, then I'm sure you know they have a habit of going wrong every now and again. But as we all know, that is part of the daily life of a developer. So, without further ado, I had a few slides to go through just to kick off with, just to sort of introduce what we're trying to do here, and then we'll get stuck in really and see where we end up at the end of these 2 hours or so. So let me find some slides. Yeah, in terms of things like questions. If you have any questions, then just pop them in the chat at any point. I will keep it open on another screen. So yeah, I'll check them periodically and answer them as we go. So hopefully these slides are coming through. So the whole point of this set of streams is to really show kind of, in my opinion, how straightforward it's become to build applications in the cloud, especially looking at serverless applications. I did a talk to Norfolk developers a little while back all about serverless, so this is a kind of good extension on that. But yeah, I really wanted to give this stream thing a go. Could be a complete disaster, we will soon find out. Apologies if my cat decides to make an appearance halfway through. She's only trying to help, but she might show her tail at some point. So I really want to kind of start with this idea of how can you be a coffee nerd. I never used to like coffee to start with, and then drank kind of more and more of it, and had one of the kind of espresso machines and kind of got used to that, but then have always wanted to be able to kind of have cafe quality coffee at home. So started doing a bit more research into it all and eventually found a kind of route into espresso that wasn't kind of astronomically expensive. I've since found that there are, once you kind of get the bug for making espresso at home, you can very easily spend ridiculous amounts of money. But yeah, as you can with any hobby. So I did spot you've got the coffee channel in the Norfolk developers Discord. So I'm sure some of you will be well familiar with the kind of intricacies that perhaps go into making an espresso. So the one thing that I never really knew was kind of how, I want to use the word scientific because it is science, how scientific that process is. I kind of had this impression that I'd buy a bag of beans, I'd grind the beans in the machine, I'd tamp down, I'd push the beans down, and I'd brew the coffee and it would be great. What I didn't find out until I'd got to the end of my first bag, and having not had a single drinkable cup of coffee out of it, is just how important various sort of variables are, and how important the consistency is between each time you make a coffee, so that you can get the flavours right and make the most of these beans. So my Christmas gift of a nice bag of limited edition Christmas beans got used up on the first day trying to learn this machine, which was a little bit annoying, but now I'm much better at not wasting bags of beans and getting reasonably good coffee every time. So there's kind of a few things that can go into affecting how good your coffee is. So I kind of split it into three things that go in, and then three things that get affected on the way out. So different coffee machines do different things, but my particular machine, I can change the three variables on it. One is the temperature, so how hot or cold you are brewing the beans you've ground. One is the amount of beans you're putting in, and one is how fine or coarse you are grinding those beans. So between the kind of combination of those three things, there's three kind of outputs to it that can be affected. So you've got the yield, which is how much you get of an espresso. So maybe it's 30 grams, 40 grams, 50 grams, whatever. How long it takes to get to that 30, 40 or 50 grams, and then naturally taste. So I won't go into sort of super amounts of detail about how different amounts of or different sizes of grind affect different things, but the real kind of key thing to remember is when we're building this application, there's these three things we're going to be putting in. So temperature, dose, and grind size, and the three things that will be output as part of this will be the yield, the extraction time, and taste. And that's what we want to be able to track over time. We want to be able to say, okay, I tried brewing these beans with a grind size of 5, I got this yield out of it, it took this long, and the taste was all right, but not perhaps all the way to where it should be. So next time I tried a grind size of 7, yield was this, time was this, taste was great. So that's the kind of thing I want to build. So what we want to go from something like this, so a bag of beans, to a portafilter of ground coffee, to hopefully a coffee that is tasty. So in terms of what we're actually building as a kind of summary, it really is a web app to track espresso brews over time to improve the taste, consistency, and waste less beans. Because for me, that's what I want. I want to be able to say, it took me 3 attempts to find the right settings for this bean. Now I know that every time I make a coffee with this particular type of bean, I can go straight to these settings and it should be pretty much consistent. Um, so I've kind of pulled from a hat a little bit a selection of AWS services. One thing I really deliberately didn't do with this stream is plan much, because I want it to be really, really raw. I want it to be something where you really kind of see how you would go about doing this for a first time. Whereas I think when you plan things too much, you end up just kind of following a checklist. Or if you're doing live coding in a talk, then you might kind of have a fallback option for, if this doesn't work, then I can copy and paste from some notes somewhere. But this time around, it's, if something goes wrong, then something's going to go wrong. So yeah, pulled some icons from a few various services that I think we will probably touch upon. Some fairly common ones in there around serverless functions, serverless databases, serverless storage, DNS, content delivery networks, all these kind of things that we don't want to manage ourselves. So yeah, that's what we're going for. Just for the kind of, this is probably the only time I'll mention this, but the kind of obligatory plug of, I work at Inawisdom. We're an AWS consultancy. If you're kind of coming into this and you are already using AWS, but you're sort of wanting to see how other people use it, we are pretty much always hiring. So if you go to the address on the screen, there's a list of the jobs and sort of job descriptions and that sort of thing. At the moment, we're really focusing on either sort of data cloud or solution engineers or solution architects who have kind of got a good grasp of the data world. If it sounds interesting, or if you kind of watch this talk and think, yeah, I know a lot of that, but I want to sort of take the next step in my career, then please go to the website and have a look, and get in touch, and Greg will be happy to have a chat. So that's the obligatory plug over. Let's get on and actually, well, let's build something. So what I'm gonna do is, let's switch back to something where you can see a bit more of my screen. Cool. Also, if I need to zoom in or anything like that on pieces of code, please do shout. So I think I put this in the description of the stream, but what I really want to try and do as part of this is build a backend using various serverless components of AWS, and to build a front end with React and Tailwind UI. The reason I'm going to use Tailwind UI is that it's quick. I can pull components in and it just isn't going to look completely shit. So that's the only reason I'm going to use that. So what I want to start with is probably to start with, it's thinking of, can we put together maybe a simple API where we can start to think about what are the resources we perhaps want to post, put, get, etc. So I think my first inclination is to go for some form of RESTful API. But the first thing we need to do is get this, Kev, I'll make this a bit bigger, there we go. I will get a SAM application going. So SAM stands for Serverless Application Model. It's a AWS first-party kind of command line tool, and it handles things like deployment, local testing, building everything you need around serverless on AWS can pretty much be handled by SAM. So the nice thing about SAM is that you've got things like templates. So we can go through this and choose our various options, and it will provision for us locally to begin with the source code and the right structure for an example AWS serverless app. So we've got two options here for this, one being zip, one being image. Difference between them is that for Lambda, so Lambda being serverless functions, you can choose to have you can choose to run your code either as a Docker container based on the image that you build, or you can choose to run it just as raw code. The one advantage of running it as an image is that you can bundle a lot more dependencies in. There is a limit on the size of Lambda functions when they're of type zip, being that you can have up to 250 meg unzipped, including all your dependencies, which doesn't sound, it sounds like a lot, but once you start pulling in some of the bigger kind of Python packages, certainly that I use for sort of the machine learning stuff, it gets over that 250 meg straight away. Image means that you can bundle all these into a Docker image, and you can run them in Lambda, and the maximum size is 10 gig, I think, off the top of my head. For this, we just need to do the zip one because we're not really doing a great deal in these functions more than just passing a event and storing it somewhere to begin with. And I'm going to do all of this in Python because it's my go-to language for daily things. So we'll call this, let's call it something like that. So it pulls down templates from the official AWS repos, and then we can choose from various different example templates they've got available for us. So for us, we'll go for this Hello World one to start with, and the reason being this Hello World one will give us a Lambda function and a API gateway, which is AWS's managed API, allows you to point your endpoints to various different services within AWS, but works really nicely with Lambda. So I'm just going to update my SAM. Oh yeah, thanks Alex. Hopefully that is better. Cool. In fact, if I just move that across as well, then hopefully any code on here won't get covered up by anything. Cool, so we've now got this folder created in here, which is where our backend is going to live. And I am going to open this up in PyCharm, and we can then start having a look at this as it runs. let's just I'm definitely going to have to zoom this in because it's small even on my screen. Cool. Hopefully that is big enough to read on there. So we've got this this structure that it builds for us straight away. So we've got the Lambda function itself that it creates with our Python file to run it. It creates some unit tests for us out of the box. It creates a CloudFormation template, and we'll come on to that in a moment. And it creates an example event, which is what the Lambda function will receive from the API gateway, and this is what it handles. So this is where we can get access to the body, for example, which might contain details about the particular coffee brew that we've just done. So let's have a look first of all at these two files here. So we've got firstly our CloudFormation template. So our CloudFormation template of CloudFormation, for those of you who don't know, is a AWS first-party templating language, format, system, whatever you want to call it, for kind of infrastructure as code. So you define the infrastructure you want, you deploy this template into what's known as a CloudFormation stack, and that CloudFormation stack references all of these resources to get created for you. A number of benefits to this being that you can really easily delete those resources by deleting the stack, and it cleans everything up for you. Also, it means that for things like obviously multiple developers working within a team, you can check the state of your desired state of your infrastructure into Git, and then you've got really easy control over that sort of thing. But also things like disaster recovery. So if an entire AWS region goes down, which is very uncommon but has happened, if you've got a good template in place, you could deploy it into a completely different region, and maybe point your DNS records to the new system as part of your kind of failover strategy. So infrastructure as code is without doubt almost always the way to go. So what we'll do first of all is we can deploy we'll deploy this particular template. But what I want to do first is I want to just sort of tidy things up a bit and rename some things so that we start off on the right foot. So what we know is we're going to want to, in our kind of project directory, have this split up into reasonably sensible chunks. So I think we should start off with let's start off with a Lambda function that will handle handle all of the routes for creating, editing, listing, deleting different types of coffee. So let's rename this to be, let's go for just coffee. And then what we can do is, there's a few ways you can kind of configure Lambda functions to be triggered. So if I just pull up the documentation for AWS SAM, I can show you exactly what you can do, because it is a very, very flexible system. And I'm going to need the documentation at some point anyway, so I may as well have it now. So what you've got is I'll pop this link in the chat. So what you've got is in the function resource, you can see here they kind of define all the different options you can provide to this particular resource to configure what you're creating. So what we've got is, I'm particularly interested at the moment in this events one. So this events property specifies the events that trigger this function. So we know this is going to be of type event source, and then there are various different types of event that can trigger a Lambda function. So you've got things like API, like we're using kind of already. You've also got things like S3. So if you want to have it be triggered by a new file being uploaded, for example. So a good use case for that might be, you've got a file being uploaded, you need to generate some thumbnails for it. You could use a Lambda function to do that reactively as soon as a new file is uploaded. Or your more kind of typical approach, where you do something like SQS, which is the Amazon queue managed service, so simple queue service. And with that, you've got the ability for a Lambda function to be just triggered and poll for messages off that queue. But it's significantly cheaper than if you had, say, a regular virtual machine in the cloud, or something running locally that's just continually polling a queue and waiting for something. Because the Lambda only runs when you've got new items to process. So we're looking at the API one to start with. So what you can do is you can configure things like authentication, which HTTP method, so sort of the get, post, put, delete, etc. The path at which we want to invoke it. Then you've got some more kind of detailed stuff in terms of API gateway models. So models are, the concept of models is very REST API like. So we may use that, may not. And then you've got things like parameters that are passed in that request. But you can also define your API separately. So you can define an API separately and then reference it with this one. So I think that's what I want to do, because I quite like the idea of having a bit more control over this API, especially as we're going to add some authentication, hopefully tonight, onto it. So let's first of all look at this API resource here. So we know it's, to begin with, going to be of type API. Let's see if we can. So we can create a new resource, and we'll just call it Espresso Backend API, and type that, and then we're going to have a load of properties that we can pass to it. So what we want to look at here is kind of what's required. So let's straight away just look for, okay, so the only one that's actually required is the stage name. So the stage name is going to be things like production, dev, staging, kind of various stages of your API, and you can then apply versioning as well on your API. So what we will do is, seeing as this is all going to be very much in development, we will give our stage name as dev, and what else can we add in here that might be useful at this stage? Things like CORS, so the cross-origin request sharing, we will have to add at some point when we start working on the front end, but that's not just yet. We'll add a description just for usefulness sake. You can do things like configure custom domains if you don't want it to use a regular AWS one. And I don't think we have to give it a name. No, that's fine. You can create your API based on an open API specification. There are some quite nice things you can do with open API. So you can, when you define your open API spec in a separate file, you can then add things like examples and descriptions to the endpoints. And then what will happen is people can open up that API spec and see in a kind of a GUI outside of AWS what those particular endpoints accept and return. So that can be quite nice to use, but generally comes into value when you've got a kind of productionized API that's being consumed by lots of people. In all of these resource references, you tend to have examples as well. So I'm going to just have a look and see if they've got an example of the models. Here we go. So I haven't used models before on a API gateway, but I'm quite keen to try. So yes, you're right, Kev. Postman can do imports for OpenAPI. There's also another application called I think it's Stoplight. Yeah. Which is great for visualizing OpenAPI specifications. So then, yeah, let's take this example here and we'll adapt it to our particular use case. We can always abandon the idea of using this models feature if it doesn't look like it's going to be a reasonably straightforward one and add new value. So let's call this model, let's call it a coffee bean model. And then this coffee bean will have a name. What else could it have? a type of roast. So different coffee beans, some are roasted lightly, some are roasted to be dark roast, and that can alter everything else. So it can alter how easy or difficult they are to grind, and flavours and everything. Then we could perhaps have maybe tasting notes, and the last one we'll add is the roaster itself. So then we can perhaps define in here our four different our four different properties of that particular model. I must say it's really weird doing this and kind of knowing that people just sat there watching. Hopefully people are going to learn something by the end of, or hopefully tonight. But if not, if you were planning to come to all four, or five if we run over, then yeah, hopefully it will give a good insight into everything. So let's just tidy up this template a little bit here. We know we've got this function now to handle perhaps our coffee bean model. So let's make that a bit more explicit so we know what we are doing with this, because otherwise I think this is going to get very confusing very quickly. And then this is going to change a little bit here, in that as it is at the moment, what it will do is it will create an implicit API. So if we deployed this, what would happen is you'd get an API gateway deployed. It wouldn't point to anything; it would just be an empty API. Then you'd get a Lambda deployed, and then you'd get another API gateway generated, because we haven't sort of told this explicitly that we've already got one elsewhere. So what we'll do next is we'll kind of point these two together, so we can start to say, actually, let's use this API that we're defining here for all of our functions that we're gonna work on later. So let's just define this out. So we want to say probably the path for this would be something like coffee bean, maybe. And I think you can, in the event specification for this and the API one, I think it supports wildcards. I'm sure it does. So I used it the other day. Let's have a look. Here we go. So we've got, by the looks of things, we can specify what they're calling greedy paths. What I don't know is whether it would also support the kind of root path. I guess we can find out, Because what I'm kind of hoping we can do here is, rather than define a different event on this Lambda function for every single sort of get, post, put and delete, if we can just define them here and do something like this, then hopefully we haven't got to worry so much, and we can handle the different types of API call inside the Lambda function, and just call different Python functions depending on what the type of what the method is for the HTTP request that's just come in. So let's yes, you can, Alex. So you can do regular named parameters. So you've got this option here, so you can set various types of parameters. So you can use like query strings, and then you can specify whether you want things like caching on certain parameters as well. So if you wanted to cache, because people are always requesting a very particular URL with a query string in it, you can get that set up. But yeah, if you were to do, say, that without the plus on it, then in the Lambda function, in the event you get back, there's this bit here. So you'll get parameters in there that you name. Yes, you could do something like that. So let's stick with this for now, because in my mind we'll have kind of probably four routes that go to this. One being list all of the coffee beans, one being get the details for a particular bean, one being update the details for a particular bean, and one being delete a bean. So we can do all of that, I think, and that'll be really cool. So now that we've got this, there's this kind of outputs section of a CloudFormation template that can be quite useful to use. So what you've got with this is you can output certain values that can be used in two ways. Outputs will always display in the AWS console. So if you want to sort of surface some data that people might use as part of development, they can be a really good way of highlighting that. You can also add to an output something like this, that for example, and then in another CloudFormation stack you can import values. So you could then say import that for example, and you'd get whatever this value is defined as here. So you can start to kind of work across CloudFormation stacks. That does bring with it some downsides in that it does create kind of really hard links between various stacks, and it means that if you want to update one that another stack depends upon, or you want to delete a stack that something else depends upon, it won't let you do it, and you have to kind of manually unwind things. But there are ways around it that I do plan on using in one of the streams. So yeah, all good. So what I'm going to do is I'm going to just output probably some useful things from this. So we'll use the we'll get the ARN, so that's the Amazon resource name of our coffee bean model Lambda function. We will also get this one. So what this is when you create a Lambda function, the Lambda function needs to have a role attached to it. And that role is part of the IAM service, so the Identity and Access Management. And that really is the core of everything AWS. So if you're trying to run something and it isn't working, 99% of the time it's because of the IAM permissions. So it's something that is quite daunting as a beginner to AWS, because there's so many different options for all the services to try and grant permission to. But what I find is a good approach is there's two approaches to it. One is start by giving it no permissions and just work through the error messages. So when the error message says, this role cannot do this, you grant it access in your template. If you get to the point where it's all working, you then know you've reached the point where that role has the absolute kind of least privilege that it needs. The other option is you can give it full admin access to everything, and then there's a service in IAM called Access Analyzer, and it will use the usage of that role over time to recommend a policy for you, which can be really useful. It hasn't got 100% coverage on all the services, so it isn't perfect, but it is better than nothing. The one gripe I have with most pieces of training that go along with AWS is it's always kind of the kind of IAM permissions are overlooked. So what you find is, without kind of naming particular providers, it'll be a case of just give your role full admin access, don't do it in production. They don't actually cover necessarily how you might go about not doing it in production. And a number of times you look at code and think, this Lambda function that all it's doing is updating a row in a database has full admin access to do literally anything, and kind of has the power to, probably unknowingly to the customer, run up a bill of millions quite easily over the course of a month, is quite scary. And Amazon don't tend to let you off when it comes down to things like that. So general rule of thumb, there's very few use cases where full admin is necessary. The only use case I can think of is a full admin role. Other than that, even full admin roles are slightly questionable. So just tidying up these comments and stuff here, so we've got something useful to look at, and we will do something like this. So we've now got this template, so what I'm hoping will happen is we'll get an API deployed, we'll get a Lambda function deployed. The Lambda function will also have a role deployed with it implicitly. Obviously we haven't defined that role, but it just gets a set of kind of basic permissions, and you can then add more, and we will add more because we need more, but it will add the relevant permissions in order to be kind of triggered by an API and that sort of thing. The one last thing we need to add onto here is to reference that we want to use this API rather than generate a new one. So on here you can specify this REST API ID, which was on the serverless function one here, wasn't it? On the events, I think, and API and REST API ID. So what we want to do is get the API ID from this serverless API resource, and what you've got in all of these templates, again, all of these documentation pages, is a list of the values you can get from them. So you've got the, wherever it went, the return values. So this will return the ID when we use this reference function. So I can go reference and then the name of this resource. So this name in the template is known as the logical name. You could name it something completely different in the console, but when it comes to CloudFormation, this is what's called the logical name of the resource. And we can reference that there. So we've now got a template that should get us started. Obviously all it's going to do is return at the moment just this default hello world template, or this default hello world message, which is fine. It'll show us that things are wired up, and we can work from there, hopefully. So I am going to log in to AWS, because that would be a really good start. This is interesting. I did say something would go wrong. Weird. Let's try going there instead. There we go. Dodgy link. This is, if you haven't used this before, and you do within your organization, you've got a lot of accounts. AWS single sign-on is a real lifesaver, in my opinion. So what you can do is you create an AWS organization, which gives you a number of other benefits as well. The biggest one being consolidated billing, in that you get one bill each month for all of your accounts, rather than getting, in this case, 5 separate bills. It makes just everything easier. But you also get single sign-on. Single sign-on is a free feature to have. You don't pay for anything with organizations. But what you can do is you can set up users. Those users can have MFA devices, both virtual and hardware. I think it even supports Touch ID and Windows Hello now, as of last year. So yeah, you bring all of your accounts into the organization, you define your users, and you can give those users what they call an SSO permission sets. And permission sets are basically roles. So because these are all my own accounts, I've got admin access and no one else uses them. But what it means is if I had somebody else doing some work in my personal production account, I could give them a role on here that was slightly less permissive, because they might just be doing work that's relating to Lambda functions or S3 for storage. And SSO makes it really easy to standardize that across a company. We used it when I was at BT within my part of the organisation, and it worked really nicely. It works for both management console and takes you straight into the actual AWS console, as well as getting command line credentials. What I'm going to do is, because I've made the mistake of this before, is I'm going to move this off my screen when I bring up my command line credentials, because otherwise everyone watching this stream can use my account, which isn't really what I want. As lovely as I'm sure you all are, it doesn't stand me in great stead if I'm giving a security talk in a few weeks. Right, so we are now back in here. So I've copied my account details into my terminal. It gives you them in the full kind of export AWS access key ID equals whatever. So you literally can just paste them straight in. So what I've done is done that, and I can now do this and just check that I am in an AWS account. Cool. So yeah, it's telling me I'm in this account here, 626836, which hopefully, let's just close some of this stuff down. Is the same as this one here, 626836. Cool. Yes. Yes, Colin, I've heard of AWS Vault before. I haven't ever had a chance to use it, but what you have got now is you can also use SSO profiles from the command line, just with the regular profile syntax. So if you were doing something like this to get a list of your S3 buckets, and you did something like that, it would pop up a browser for you and let you sign in with your SSO credentials and manage it all as part of the native AWS command line. Alex, your comment about the runaway charges, I think it depends on what it is. There are obviously a number of stories you kind of see on Twitter or Reddit where people have sort of seemingly genuinely made mistakes. I think from what I've seen, if it's, I mean, obviously I can't speak for AWS and don't pretend to. From what I've seen, you generally, if it's a genuine mistake and you can prove that it's a genuine mistake, then Amazon do sometimes kind of give you a pass for one. But that's by no means binding. Don't hold me to that. Yeah, when it comes to things like security, I don't know how it works. What I do know is there are, if you are using AWS for something where AWS is making you significant money, you've got things like AWS Shield, which is their managed DDoS protection. And I'm sure those of you in here who are Laravel users are familiar with Fathom Analytics. So they did a great blog post on AWS Shield and why them spending, I think it's like $36,000 a year or something on it, was worth it, because what you find is that when you're using the premium AWS or the advanced AWS Shield, you do get I think it's Shield. There's a warranty you get. Oh yeah, here we go. So it's the cost protection. So if you do get DDoSed and your resources scale up as you'd hope they do, what will happen is you can reach out to your AWS support team, who, if you're spending $36,000 a year, you probably should have support as well. You can reach out to them and they will give you some credits to account for the extra spend you've had to have as a result of the DDoS. That isn't in the standard tier, just in the advanced one. But obviously if it scales out that much, then it's quite easy to spend $36,000 in one DDoS incident. So it can pay for itself very, very quickly. Yeah, a little bit of a tangent, but if you're making that kind of money from AWS, then it probably is worth looking at. So we're now logged into this. We've got all of this working. So what I'm going to do first is, well, we can deploy. That's probably the best place to start. So let's bring PyCharm back up. So we've got everything ready to go. Yeah, let's see what happens. Can only go one of two ways, can't it? So we can do, there's sort of two steps you can do to the process. You can do SAM build, and what SAM build will do is it will take your function that you've got, and it will look at the requirements file for Python, or in the case of kind of your JavaScript Lambda functions, it'll look at the package lock JSON, or whatever your language of choice is. It'll build all the requirements for that. So if we now look in this SAM folder, you've got this coffee bean model function, and you've got these Python libraries that obviously we've asked for the requests pip package, but these here are all going to be part of the dependency tree for requests, so they come along with it. This is where Docker can come in handy. So what you can also do is, I don't know if I even have Docker installed in here. This is an M1 machine, so Docker could go horribly wrong, but I'll try. You can also do things like this. You can do SAM build container, and SAM build container. I'm sure it is. Oh, it's a use container possibly. Is it use container? Use container. There we go. It'll then build your dependencies inside a Docker container that is reflective of the target environment your Lambda will run in. So what this means is that if you've got dependencies that get built from source, so the ones that come to mind are generally sort of database drivers and stuff like that, are often written in C, and then when they get compiled up, they then get used as Python packages. So to make sure that build process is consistent between this stage and when it's running, and that those dependencies aren't going to go horribly wrong, you can build in a container, which is very, very useful. If you're sort of using this at work, obviously there's now the caveat of if your business is over 250 employees or $10 million turnover a year, then you have to have the Docker licenses. But I think it's like $7 a month or something per person. But I think the team behind AWS SAM are looking at alternatives if you don't want to use Docker. But I'd argue that if you're making $10 million a year, and SAM is part of your daily workflow, that $7 a month probably isn't gonna break the bank. So anyway, we've built this all up now. So next we can just go ahead and deploy it. So you can run SAM build or SAM deploy rather. And the first time you deploy it, you can use this guided mode. And what it'll do is it looks for a config file in your directory called samconfig.toml. And that config file will contain all of these things that we're about to define. So on subsequent deploys, you can just do SAM deploy and it will go for it. So let's call this something like espresso backend API. So I think later on we'll perhaps have some templates for things like databases, which might want to be separate to this. We can specify our region. Always a bit of a debate about which region to use. The two, I guess for us in the UK, is going to be EU West 1 or EU West 2, 1 being Dublin, 2 being London. When it comes to choosing a region to run things in, Ireland tends to get features first. But if kind of latency is of the utmost importance, then depending where you are in the UK, London might be a better choice for you. But I'm going to use Ireland today. And then you can confirm changes before deploy or not. You can set this once and then it will take account of your choice every single time. I'm going to go for no because for any of you who watched the last serverless talk I did for Norfolk developers, I spent a good 5 minutes trying to debug why my application wasn't deploying, and it's because when I was asked, do you want to deploy it, I just clicked no every time, which naturally didn't deploy anything. So we're not going to do that. And we want the SAM CLI to be able to create roles. And then this is quite nice in that it does warn you when you're deploying APIs that haven't got any auth on them already. So I'm going to click yes, because if you say no, then it won't deploy. So we need to allow it. And then we want to save these as well. And we'll save them to here. You can choose different config environments in this TOML file. So you could have one that's kind of dev, test, and prod. For now, obviously, we're just going to be deploying into one account for all of these streams. So I'm just going to go for the default one. And this will go ahead and then deploy our stack. And hopefully, because I haven't got the AWS Shield Advanced protection on my account, we're not going to get a horde of people go and DDoS the API and cost me a fortune, because I don't think Alex will be too impressed if I turn around and ask for the Norfolk developers budget to pay for that. this is looking pretty good so far. Seeing lots of green, which we like to see. Lovely. So if we look in the console, we can see, if we go to Cloud Formation, so we've got in here this stack that gets created by default when you use SAM, and that stack has things like an S3 bucket in it, and that S3 bucket is used if we look back at the list of things that happened here. It uploads the contents of our sort of template, and any it'll upload the function that we built to S3, so that then when the CloudFormation stack gets run, when you look in here at the template, you'll notice is it in here? No, it's in this one. You'll notice the code URI has been translated to be this. So it's actually referencing in that bucket the function that we've built locally, gets uploaded as part of the deployment process, and then obviously the template gets transformed so it can reference S3 instead. So this looks like it's all created fairly successfully. So we can now look at things like API gateway, and let's just tidy up some of this. So we've got our API. We can see we've got this model created here, and we've got our proxy route. And what we should find when we click through this, the integration is a Lambda, and then we've got our actual Lambda function here. And then on the way back, it's just going to get returned back to the client. And when we look in here, we've then got our coffee bean model, which is kind of as we defined. And we'll see later on actually what this model actually adds to using APIs, and see whether it's useful or not in the future, because I've never used it, and it'd be nice to see what you can use it for. Right, so we've got all of these. My thinking is now, let's bring up, have we got Postman on here? No, Postman Pat, that's not what I wanted. You can tell this is a new machine. Cool, so I'm just gonna drag that into my applications folder and Postman. Cool. You can zoom in this. How could you do it? Right, so let's start by trying to hit the API, shall we? See what happens. Hopefully we'll get back a hello world. So we've got this here as our kind of route for our API. So let's bring that over to Postman, and we'll start with the GET request, shall we? And then we know we've got a route defined here. And we should find that all of these requests, regardless of what we put after coffee bean, will get routed through to that Lambda. Lovely. Part of me was not expecting that to work first time. So far so good. Cool. So let's just try some other things. Lovely. And then if we tried something like a post to coffee bean, what happens? Okay, so that doesn't work. But if we do post to that, okay, so it looks like in order to use this proxy here, you would have to have maybe two routes, one for the kind of ones that go to just this path here, and ones that go to anything but, or anything over on top of that rather. So what we will do is, let's just duplicate that. And let's do something like this. So we'll do it for any method, and we will do for this one espresso backend, something like that. So now we can just do SAM build. We don't need to use a container because we haven't got anything that's super. Anything that needs to be compiled from source or anything like that. So we can do SAM build and then SAM deploy. This time we don't need to use the guided option because we've already defined all of these options in here when we did it the first time round. So we can just do SAM deploy and it will do it all for us from that file. So we can see the change set it's created. So it's saying, let's add a new deployment of the API, which is correct. Removing the old deployment is going to add permissions to the Lambda because we changed the names of these. So when it refers to these Lambda permission resource type, it's talking about the permissions for something to invoke Lambda and for Lambda to be invoked by something else. So we are saying here, this is creating a permission resource and it's for, in this case, the greedy API path that we created to invoke that Lambda. Same for the root API path. How is this done? Cool, all done there. So if we look back in here, what we'll probably see now is, two. So we've got one route here, which is for any method at the root of that path. And then we've got another one, which is for any method at the under that kind of greedy proxy. So now if we try again in Postman and we post to that, we've still got hello world. If we imagine we are creating a new coffee bean where we want to post to the root of this coffee bean resource, we're getting hello world, which is perfect. And then if we're doing, say, a get so that we can get a list, cool. So far, this looks to be wired up pretty much how we want it. So what I wanted to look at next was how we handle the different routes in here. So how we look at this and say, okay, the path that's come in is the root of this, and it's a get method. Therefore, we want to handle it by returning a list of different coffee beans that we've stored in our system. So let's go into this app py, and we'll keep this, but we'll just start to bootstrap a few bits where we know we don't need any of this stuff anymore. I'm going to take the comment out just because it's going to confuse things in a minute. So what I've got now is if we deployed this again, obviously we get an empty body back, which isn't what we want. So what I am going to do actually is, as I go along, so that we've got something we can sort of look back on, I'm just going to commit various bits as we go. So I'm pretty sure this isn't going to have AWS SAM in it. So we don't want to, well, like most built artifacts in software development, we don't want to be committing this here. And other than that, we're probably good, apart from the JetBrains configuration files that get put in there by my IDE. So if we look at this now, what have we got? Yeah, that's all fine. So let's just and at some point I'll get this on these, well, we'll have a front end repo as well. I'll get them on GitHub. Right, so what have we got to do? So we need to handle this lot in here, don't we? So there's a really great package for working with lambdas on AWS, certainly in this kind of scenario where we are handling multiple paths in a single lambda. Generally, I'm kind of against trying to give a lambda too much to do. Alex, your comment about the two Git commit messages, what it gives you is it separates them onto separate lines. So you then, this would be the commit message you see in GitHub in the kind of summary, but you'd get like 3 little dots next to it, and you can click there and get a bit more information about it. So it's useful if you're kind of making a change that is perhaps a bit too big for a sort of 50 character commit message, but you want to add a bit more detail to help when you come to either putting a PR up or when people are flicking through the history on a branch. Hope that helped. So yeah, this way of working better with lambdas. So there's a library called AWS Lambda Power Tools. It started off, I think, as something that came out of it might have been the AWS Professional Services division, but it's now kind of run by AWS solution architects, but it is fully open source and everything, so people do put contributions into it. So what you can do with this is a number of things. The documentation is much better than the GitHub repo. It is at the moment stable on Python, Recently, I mean, sort of within the last month or so, they've released a TypeScript version of it as well. I don't do a lot of JavaScript, certainly not at work, so I haven't used that yet, but I've heard it's quite a good start. So yeah, the Python one is stable, has been stable for a long time, or a long time in the world of cloud anyway. And yeah, this gives you some really nice things in terms of logging, monitoring, but just general helpers for using Lambda. So there's a couple of ways you can work with it. The way I tend to prefer to work with it is with this Lambda layer. So for those of you who haven't used Lambda before, the idea of layers is that you can kind of put repeatable pieces of code that can be shared across multiple lambdas. So for example, if you've got a for our function here, so when we start to work with a database, for example, then the ability to communicate with that database is going to be pretty common across every function we use. So what you can do is you can create a Lambda layer, and Lambda layers just contain dependencies for a function, but can then be reused across multiple functions. So it means that it's just that whole principle of kind of don't repeat yourself, and it makes things a bit more maintainable as well, without having to go through the hassle of publishing a package to pip or something like that, or maintaining your own private registry. So let's is it going to paste in or not? No, it's not, is it? So what we've got in here is you will notice that I'm using this sub function here. So anything with an exclamation mark in front of it, or you'll sometimes see it written as like that instead. Anytime you use that, they're called intrinsic functions, and they're just ways you can process data inside your template. So this sub one stands for substitute. So we can substitute values into a string. So what we're doing here is we're substituting the AWS region that we're deploying into this string, so that we make sure we get the right layer. But you can also do things like substitute, I don't know, for example, the name of a or the reference value of a resource in your CloudFormation. So like how we did down here with this, where was it? Here, yeah, Espresso backend API and this ref. So when you put a name inside this kind of dollar in curly braces within the substitute function, it's calling the equivalent to that sort of thing. So it's really useful when you're trying to use values after kind of a model has, or after a resource has been created. If you've got to append a prefix or suffix or whatever you need to do with it, it's just another way you can manipulate a string in CloudFormation. Alex, the limit is 250 megs unzipped, including layers. So this is quite a common problem people find with Lambda, in that, as I kind of said earlier, your 250 megs doesn't go very far, certainly with some Python packages. So you can move things into layers, but the limit still includes them. So what people tend to do is, if you know that you are only using part of a library, for example, and you absolutely have to use Lambda for that library, then I've seen people have like sort of processing steps as part of their deployment, and as part of that deployment processing step, they'll remove from this build folder, they'll remove part of a library. So for example, if we knew that I don't know, we weren't using the auth part of requests, and this part was going to take us over the limit, people would remove that as part of the deployment. It's a very hacky way of doing it, and I wouldn't use it, I think, unless it was a case of like, this is going to fail, and is the only way to do things. It basically is minifying, but completely removing, so it's almost like an extra level on top of minifying. I guess with things like Node, it probably isn't so bad, because you have got generally those built files and your dependencies are smaller as a rule, but Python ones do tend to be quite bloated. The other way you can do things is with those image types, and the image type for Lambda rather than the zip type, which gives you 10 gigs. That does require a little bit of knowledge of Docker, but with that starter template you can choose, you do get a good helping hand on it. But yeah, what you'll find is that with that you can't use layers with lambdas that run Docker images. So there's swings and roundabouts to all of it. But I generally think that if you're using dependencies that are so big that it's more than 250 megabytes, there's kind of an argument for, is Lambda the right choice? So things like Laravel apps, the 250 meg isn't gonna cut it. So Vapor will use the image type of deployment rather than anything else. But it's tricky. It's tricky. But yeah, anyway, so we can import this layer here, and then when we deploy, it will attach that layer to the Lambda, and we'll have access to the dependencies inside this. So what you can do in this is, like I said, do all sorts of things like distributed tracing, logging. You can do custom metrics, all sorts of really nice stuff. The two that I tend to use is tracer and logger just by default. Every Lambda I'd put these in. The reason being that they don't cost a lot. It's all relative, so the more your Lambda gets used, the more traces it will generate and the more logs it generates. But it does help with debugging, especially in production, because you still get those traces, but they're not detailed enough to reveal kind of sensitive information like perhaps logging might be. But it will show you, I can show you when we get to that stage, in a service called AWS X-Ray. It will show you through the kind of the stack of which functions have been called and when, and which functions have taken the longest, and loads of really useful stuff for profiling your Lambda, which is nice. So I'm going to just quickly chuck these in here. So I'm aware we're starting to get a little bit close for time tonight, and I'd really like to get to a stage where we've at least got kind of the API routes defined inside the Lambda and handling some of them in terms of we are posting and stuff. It's not going to persist anything because we're not going to look at databases tonight, but it will at least return something that identifies that it is a post request. So what we want to do is we want to add an environment variable as well, and then this will determine obviously what it gets called in the AWS X-Ray console. So let's call it that, for example. This tracing active bit turns on the tracing. Then we've got these two or these three bits here that we need to add to here. You can also define it in here, so I think you can do it like this, or you can do it with the environment variable, or underneath, service. So I tend to prefer the environment variable because it keeps us a bit more clean, and you're not really hard coding into your kind of source. You could reference something else for this, or it just makes more sense to keep everything abstracted a little bit of a layer up. And the other one I want to import is the logger. So the logger is obviously with Lambda you can just do in Python print statements, but what you find is with this logger it logs in a structured JSON format, and with that structured JSON format there's a feature in AWS CloudWatch logs called logs insights, and you can run SQL like queries. It's not SQL, but it's a structured language, and you can filter on things like, for this example, level. So you could say, okay, show me all of my log statements from the last hour where the log level is warning or error, and then timestamp obviously is useful there as well. It's a really handy one to make use of. So yeah, that's another one that's in my kind of go-to toolbox for getting the Lambda set up. Cool, so we've got these two set up now, and the final bit of power tools that I'm sort of really interested in. Oh, thank you, Alex. Good spot. This is what I need all the time: is someone looking over my shoulders to spot typos. Save me loads of time. The last bit I want to look at is I think it's this one. Is it this one? Yes, it is. So. What have we got? API. This is all defined. We've defined our event like they've done in their example. So we want to do this here. Cool. So this is a sort of thing you can do. So you can use a Python decorator with this, and you can decorate a function, say, okay, this function this function in particular is going to get triggered when this path is hit. So what we'll do here is we'll start to pull this stuff in from there, and it does start to change the structure a little bit of the application file. So we know, for example, that this function is going to handle, let's start with a GET request for just that root coffee bean, for example. And let's call this list coffee beans. And I think that, what does that get? Anything? No. So when you can define path parameters on this, and when you define a parameter on here, it then passes it in as a parameter to your function. And again, we'll add this tracer on here as well, so that we make sure we catch all of that. And what I want to do is we need to update this one here. So I think you just do return app dot, what was it, resolve. There we go. So what it's doing is essentially Lambda Power Tools is handling all of the information that comes in, resolving the event. It'll look at this event event type format here. It'll look at the resource, it'll look at the path, the method, parameters, all these fun things, and match it up to something you've decorated. So what I want to do last of all, just to test this one particular route is working, is we know this is going to be a fairly standard format for our responses, because that's what API Gateway needs. So I'm going to just create here a function called format response, and let's have a parameter called status code and a parameter called body, and then we want to return something like this. What we'll do, I think, is we'll do that and then that. And then we can add this capture method on here as well. So what we can then do is we haven't got to worry about duplicating this every time. We can, in here, we'll just, for argument's sake now, we can do something like body equals actually let's make it a bit more JSON like, and then I don't know, what was my most recent one? I think it was literally just called Brazil, and it was from if anyone does make espresso at home, it's a very nice coffee bean. I can recommend them. With this capture method decorator here, you can add something, I think, where you say, I'll just double check the wording of this. You can put this in. So let's just check. There we go. Yes. So what you can do with this is you can say, I don't want to capture the return value of this function. So it will show you the function's been called, it will show you how long it's taken to execute, but it won't store the response to it. So that's where it's quite useful if you are returning perhaps things from an API. I don't know if it was a banking API, for example, you probably wouldn't want to be tracing the response values. Tracing the response values in Amazon X-Ray, because you just can't apply the same rules around keeping that data secure and everything as you might be able to if it was in a database or in logs or something like that. Obviously, one thing you kind of have to think about is this does bubble. So if we said, okay, don't capture the response of this and don't capture the response of this, because it is still being returned from this, you'd have to sort of do it there. So you have almost got to kind of trace it through the stack of that particular call, but that's fine. So let's just go back and look at this event handler. The photo in my slideshow column was my personal machine, and the reason it looks like your portafilter is because mine is also a Sage machine. Mine is the Barista Express, so it's got the bean hopper on top of it, which, yeah, the idea of it is you pour your bag of beans in and then you set a timer on the front to say grind the beans for, I don't know, 15 seconds, which doesn't really always work. So I've gone down the route now of weighing the beans first, pouring them into the hopper, then grinding them, so you make sure you get the same amount of coffee every single time, which again helps with that consistency. It's amazing what the idea of having to buy multiple bags of coffee drives you to. I think if you are looking to change, the way I would probably go next would be to have separate grinders and espresso machine. So again, obviously it all depends on how much people want to spend, but yeah, a separate grinder that is really consistent, and then even something like your duotemp machine would be really good. I think the grinder is what lets down the machine that I've got, but I'm trying not to tell myself that too much, otherwise it'll be a unnecessary purchase. So we've got this all set up here now. Hopefully when we deploy this, we'll get from this response here, we'll get this sort of dummy list back. Let's get that moving now, just in case it takes a little while to run.
Before anyone has any ideas, I'm going to delete the stack after each stream so that the unauthenticated API doesn't sit there for a week whilst I'm on holiday to get home to a huge bill. Even though I think I've got some credits left on my account, but the credits mean I can do demos like this and not have to worry about paying out too much.
How many people did we get in the end, Alex, attend this? I know we had about 25, 26, I think, RSVP'd to the meetup, and then I shared the link around work a few times. Cool. This seems to have deployed, so let's see if we can get this working. One thing I don't know, I haven't actually tried this before, is what happens if you hit a route that isn't defined in here. I'd hope you get some kind of default 404, but I don't actually know. So this will be an interesting one. Oh, cool. So we might want to think about how we're outputting this, but it has output obviously this, but what it looks like it's done is, oh, I know why. The power tools, I think, use a different format. You can, in order to trigger particular HTTP errors, you can raise exceptions in Python. That's fine. So in terms of actually returning values, I think we can probably just return. We just return the dictionary, and Power Tools takes care of the rest, so we don't even need to worry about that. So let me just tidy this up a touch, shall we? And then get rid of that, don't need that anymore. But we know that's worked. It just isn't in the format that we exactly wanted first time, but that's all right. So if I then did something like this, curious how it handles slashes. Okay, so it does actually return a 404. Whether or not that's desired behavior for it to handle a slash, I don't know. I might have to sleep on that one. But let's just deploy that again, and then we can try. I think my plan for the next stream, based on how this one has gone, is to get the database up and running, and I'm going to use DynamoDB for that, and then get some data persisting and start making those real kind of live links between lambdas and a data store. And authentication would be really nice as well. If I could bundle authentication and get a kind of bootstrapped front end in, that would be really awesome next week. And then one thing I kind of had an idea of, but whether we'll get as far as that or not, I don't know, is that I'd really like to use one of the AWS managed machine learning services. One in particular, which is, there we go. How lovely. So it returns with a 200, okay. Cool. It's an interesting format actually, because if you're parsing this from a client perspective, I think you'd want it to be, you'd want there to be a status code all the time, so that you can check that status code. Might have to think about that. But yeah, so this is, I think, a really good start. We've got API set up, we've got a Lambda set up to handle that particular route. Then what we can obviously do next is we can start to sort of bootstrap some of these other methods. We've got 5 minutes before our kind of scheduled end, and I'm going to try to keep to 7:30 because I know that people probably had long days at work, and whilst the subject of coffee does keep whilst coffee itself keeps you awake, the subject of coffee might not. So I'm going to do one last function just to see if we can get something dynamic working, and then we will call it a day, I think. So what I want to do here is I want to do one for the for getting a specific coffee bean. So let's call it get coffee bean, and then in here we'll have, I think we'll have to have like unique IDs or something, which is fine. So let's just look back at the docs and see how this is going to work. Okay, so you specify with the triangle brackets, and then we get it returned as a parameter in here. Cool. That's fairly straightforward. So we can do something like that. And then from this we can return, I don't know, like ID is ID. Obviously in kind of real world we'll be querying DynamoDB to get back the right details for this. What's this complaining about? Shadow's built-in name ID. Maybe we'll do like bean ID instead. And again, we'll use that same example. Not quite sure yet how the API gateway models come into all of this, but I might have to do some reading of that before next week. Cool, so that has deployed. So I'm hoping so this can be probably at this point any ID we want to give it. So let's just give it something like that, and hopefully we'll get back, fingers crossed, there we go. So we get that back. We can use this value to query the database. Obviously if we change this to something else, we're going to get back that instead. So that's all working really well. I think that's probably a good point to stop. So just to recap, we've kind of covered across what SAM does, how sort of straightforward it is to set up a API and a Lambda function to serve sort of multiple routes, and how inside that Lambda function we can target which routes we're handling with which particular Python functions. So I think we made some good progress tonight. In about an hour and a half, haven't we, from when we actually got coding. So hopefully see some of you again next week. Or all of you would be lovely. And yeah, have a good evening. Just to your point, Colin, I think there is now a SAM. Is it SAM and Terraform you can use? I saw something on Twitter about it. Maybe it's Terraform and the AWS CDK. I know that AWS are doing a lot around Terraform at the moment, and certainly sort of know it's a very widely used tool, and people are aware and working on things. So all hope is not lost for Terraform users. But yeah, thank you very much for spending a couple of hours this evening listening to me ramble on about AWS and coffee. I'm now going to go make a coffee because I've done this straight from work, and yeah, hopefully we'll see you all next week.